All right, today is June 23rd, 2016. Right now at 9:35 p.m. in the foothills of Los Angeles, we have a temperature of 70 degrees. The relative humidity is 70%. The barometer is reading 29.97 inches, and we have a dew point of 60 degrees. And today it was much cooler. I don't think it even got into the 90s today. Probably the mid 80s, 86 degrees maybe. Um, all right, so we're watching the Northeast Pacific water vapor loop, and there's a forecast that we're going to have some hot weather. I've mentioned that hot weather for the weekend up in the triple digits, they're saying, for the valleys of Southern California, and also wind up to 50, 55 mile per hour winds. Well, let's take a look at these maps, and I think we can figure out why that's going to happen. First of all, we can see way over here in the Gulf of Mexico moving to the northwest. Right here we have a counterclockwise spinning vortex, and this is really not marked on the maps. Let's go take a look at that right now. This thing down here is has the attention of these transmitter operators. We can see a large dry area that's been built out with a transmitter. We have monsoonal thunderstorm moisture getting sucked into that vortex right here. We can see that behind this NOAA icon. And what is happening here, they are trying to isolate this system as it is moving to the northwest. We can see that. So what's happening here is that they are building a blockade here to prevent all of this unstable thunderstorm activity from getting sucked into this low pressure right down here. Now, if we look at the National Hurricane Center map for the Atlantic, we can see that they've got a disturbance marked right down here over the land of the Yucatan Peninsula. 20% chance of hurricane formation, it says. All right, but if we look back at these maps here, the eastern U.S. Water vapor loop, we can see that this is quite a distance from down over here, which is where they're identifying the disturbance. Now, here's the Gulf of Mexico map. We can see that this is the likely area that they are that they've marked, which is right here. So we'll go back and take a look right here, and this is also being blown apart. We can see the blast wave right there. All this stuff is turning into steam. We can see this white blast pattern. That's all the hot water vapor that's shooting out. We have the color change and so forth. But up here, we have this thing moving to the north west, and I think that's what's going to cause the events, our weather events here on the west coast. So what's going to happen, I think, is that since this is moving to the north west, we've got all this monsoonal moisture. We can see what's happening here. This is all bowing out to the west. This entire chain of thunderstorms is moving slowly to the west. It's being pushed to the west by this high pressure. This we have a phased array transmitter cutting a path right through here, dry, hot air, and that's maintaining separation between all of this weather and this low pressure spinning vortex. So what's going to happen is that in order to prevent all of this rainy weather from moving into California and delivering rain, these weather controllers are going to install high pressure right here, and that's what's happening, and that's why we're going to have these hot temperatures. I think that's the plan. We've seen these transmitter operators, they've gone to great lengths to stop the rain in California. So I believe that's the plan. We're going to watch as this state right here is completely surrounded by water vapor. We've got a low up here, upper level. We have an upper level low here with the transmitter. These both have transmitters on them, as does this one over here. So we got three lows. These two here primarily are the ones that could bring some rain into California, but they're not allowing that. That's because of all this high pressure. We can see that as this continues to move to the west, because of this system here, we've got, let's go back again and look at the east coast. Anywhere this moves, it's going to merge with what's happening here. All this monsoonal flow is going up to the north and then out to the east. That's the prevailing weather flow right here, up here anyway. Over here, we've got this thing moving to the north west. And then we have this, let's go take a look here at the, right here, we have this disturbance right next to this thing. So, but this is getting all the attention. If we look at the maps, it's clear that this upper level low pressure system is receiving all the attention. You know, they are blowing these things apart. That's just a matter of hitting these with microwave. We've been watching that all week, all year actually. But this thing here has got some momentum. It's moving to the northwest, as I've said about 5 times now. So as this moves, they've got a plan for that. I suppose they could stop this from moving. Maybe, and the other thing is here, if I can stop stuttering, I'm actually a little excited over this, but it could be that they've got some pressure behind this system to move it away because we've got this disturbance here. And if this disturbance and these two items, these two weather systems merge together, we could have something much more serious. So it could be, it's very possible, looking at the, if you look at the Hurricane Joaquin videos from last August, late August into September, you can see that that hurricane was pushed around just like what we're seeing right here. This is a very large vortex, and it could be that it's very possible that they are moving this out of the way deliberately to get it away from this disturbance down here. And in doing that, they have to maintain separation, all this monsoonal moisture that we're seeing over here. Let's take a look right here. So as all this moves to the west, they're going to have to do something about preventing rain in California, and I believe that's where all the hot weather comes into play. So this stuff here, all this monsoonal thunderstorm activity will be steered by the high pressure that they install right over California. So that'll bring us the triple-digit heat, the wind. I believe we'll have a lot of wind because of what's happening here. We've got all this unstable air as this moves in. We'll just have to see what happens. But last night's video, we had a lot of moisture in here that just sort of evaporated. You could see it disappearing, and that's pretty much what's happened here. We have this upper level low. The moisture from this is not really getting anywhere. This is all being cut off. And these are fairly severe thunderstorms right through here. He's right there. So I have to keep an eye on those and see what they do. This upper level low has been sitting here for about 5 days. Now it looks like it's starting to move to the east. And I think that this is now going to move to the east, and that will help with the overall plan, the weather plan. We'll have to see what happens. I'm a little perplexed a little bit on what exactly is going to happen here, but we've been told that we're going to have very hot weather, and so we'll just have to wait and see what they give us. Here's the southwest infrared map. We can see the intensity of these storms. This one here has been superheated. That area right there has been superheated. We can see the hole right there that opens up, and we can see the color change. And this guy down here will be next, right down here. Get him next. All right, let's look at this in the rainbow loop. Okay. But notice that nothing is getting into California. This is about as far as the moisture is getting. We're not even getting into the Colorado River. If these were over the Colorado River, I'd be toasting with a glass of champagne or something, because we need to get water into these reservoirs along here. Hoover Dam is very low, but this will everybody that's subscribed to this channel, keep an eye on how they manage to keep the rain out of California. They keep it out by blockading it using high pressure. There's a variety of techniques, and I'm going to try to feature all of that during these videos that I do daily, pretty much daily. All right, here's the visible light mode. We can see that we're not getting much detail here. They've photoshopped over the top of this big thunderstorm system. This has got Photoshop layering, and that hides the detail of the microwave blasts that I showed earlier. Today's video, the first part 1 video. If you take a look at that, it's about a 3-minute video. It has some great detail of the destruction of a large thunderstorm supercell over Kansas. Okay. All right, let's go back and take a look at some of these others. We've seen that. Okay, here's the surface analysis map. We have a huge area of high pressure here in the East Pacific Ocean. We've got a developing gale marked here at the surface level. This is all surface pressure right here. And here's the sea level pressure analysis. We can see the same information here. We have a lot of high pressure installed out here on the East Pacific. We have a low pressure indicated right all through here. California, Utah, or actually Nevada, Utah, and part of Colorado and Montana. It looks like Wyoming. That's all low pressure. All right, let's look next at the 500 millibar map, and we can see the upper level lows we have. These have been parked off California for several days now with transmitters on each core to prevent further development. And that's what they do. They put a transmitter right on top of the core, and those upper level lows will not produce moisture or rain for the West Coast, mainly in California. All right. We have high pressure right here that's showing up now on the 300 millibar. Let's look at, or rather the 500 millibar, excuse me. This is also high pressure. Okay, let's look at the 300 millibar. And we have these two upper level lows. We have low pressure indicated here. We have high pressure all through this entire area. And we had that gale indicated on the surface map right over here. So we'll have to keep an eye on what happens right here. But we are in for more hot weather and wind. And I believe that this is all a result of what is going on here on the East Coast. So I believe that the hot weather is going to be generated by this system moving towards the northwest right into Arizona, New Mexico area, and that's going to force all this monsoonal moisture towards California, and that's a big no-no. These weather operators are depriving California of needed rain, and so the plan will have to be to install high pressure to channel this straight up and out to the east. So it looks like these states here are going to get a lot of rain for the next few days until they do something with this. This has got all the attention right here. Got a very large channel of dry air in there between all this weather and that low pressure. So we'll keep an eye on that, and we'll do another update later. Okay, that's it.